Hello, I'm Tim Dyer. I'm covering a digital fan controller that I built for EE101, Introduction to Electrical Engineering, for spring of 2022. For the overview, I'll talk about what the digital fan controller does, the troubleshooting I did building the circuit, what I plan to do with the device, plans for improvement, and what I learned. This is a fan controller. It has a IRF Z44 MOSFET relay that I've cut the top off so that we could see its motion, and then a 12 volt fan that is 0.05 amps. Essentially I have a DIO 0 coming in from the yellow. I've got a green ground wire and then 12 volts on the from wall power. White is ground, red is the positive. I have that wired to the MOSFET. So positive basically runs to the fan positive position as well as the relay. White is connected to ground for the LED as well as the digital input, and the center position for the MOSFET turns on when the digital input 0 is approximately 3 to 5 volts. When that comes on, it magnetizes the relay, and then the relay switch is on. It allows power to flow directly from the wall power through the relay and directly to the fan, bypassing the digital components. I'll turn it off by switching the digital writer to 0. You can hear the click. LED's off, the relay is switched, and then the fan is off. I'll go ahead and turn it to on, DIO to 1, 0 to 1. LED turns on, fan turns on, you can see the relay. I'll just do that a couple times. There you have it. This is my EE101 project for a digital fan controller. This would have capability to power larger devices safely by using the relay and the MOSFET to allow something small like a Arduino or computer or a little thermostat to actuate the fan, but still have a large wattage or power output for the fan. Thank you. Our plan for this circuit is to use it to control a larger fan. I'd like to use it for a 12 volt attic fan for ventilation. I'll need a larger relay like the one you can see on the right that can handle more power. Also need a larger fan that you can see on the bottom, and then some fuse protection with that larger amperage to prevent any fire or damage. I learned on this project that a MOSFET was a pretty useful tool to convert the digital voltage to on or off switch for some decent current, but I also realized that's also going to heat up with higher amperage, so the relay seemed to be a good tool to isolate the higher amperage and protect the digital circuit. I learned not to solder too much because that can cause some shorting. And I also learned to modify the design when I saw room for improvement. So in this scenario, I added the LED next to the DIO so I could see when the DIO was on or off, even if the rest of the circuit wasn't working properly for troubleshooting. Overall, it's a fun project, and I look forward to making improvements on this circuit. Thank you very much.